By the end of the 19th century, Melbourne stood at a crossroads. The city had expanded rapidly during the gold rush, but its infrastructure lagged behind. Streets were lined with open drains, cesspits overflowed into laneways, and raw sewage flowed directly into the Birrung. Disease was rampant. Typhoid and dysentery weren't just occasional outbreaks, they were part of everyday life. A city in crisis needed more than incremental solutions. It required a fundamental shift in how it managed waste. In 1891, the Victorian government established the Melbourne and Metropolitan Board of Works, i.e. the Board. A bold move to centralise responsibility for drainage, sanitation and water supply. The board was tasked with designing, constructing and managing a modern underground sewage system for a city of more than 500,000 people. This wasn't just an engineering project, it was a public health imperative. At the time, few cities in the world had fully functioning sewer networks. London's system had only been completed a few decades earlier, and Paris was still developing its underground infrastructure. Melbourne aimed to join this elite group, not just with a basic network, but one of the most comprehensive and forward-thinking systems of its era. The solution was simple in principle, but ambitious in execution. Wastewater from homes and industries would be collected in a network of gravity-fed underground sewers, directed away from the city and treated before being discharged. Designing such a system for a city that had already been built posed significant challenges. The board had to map the entire city, block by block, to determine elevation and gradient, design sewer alignments to ensure gravity could move waste efficiently, minimise disruption to everyday life during construction, and create a long-term system that would support Melbourne's growth for decades to come. In the late 1880s, before the board was formally established, a young civil engineer named William Thwaites began developing a concept for Melbourne's sewerage system. His earlier proposals, based on local knowledge and practical hydraulic planning, were submitted to the Royal Commission into Melbourne's sanitary condition. Thwaites had already identified many of the design principles that would eventually underpin the final scheme: gravity-based sewers, a remote treatment site, and a dual drainage approach to serve different parts of the city. But in a colonial culture that often viewed British expertise as superior, local talent wasn't always trusted. In 1889, the government sought international endorsement and invited British engineer James Mansergh to consult on the works. Mansergh, then a leading figure in public sanitation in England, was considered a safer political bet. His presence lent the project credibility in the eyes of Melbourne's elite and policymakers. Mansergh developed 8 different sewerage schemes, each proposing alternative routes, outfall locations, and treatment concepts. Among them, Scheme M emerged as the preferred model for its balance of practicality and efficiency. It proposed 2 major intercepting sewers, one for the eastern half of the city and the other for the west, delivering sewage to a treatment farm well beyond the urban fringe. When the board was created in 1891, Thwaites was appointed as the first engineer-in-chief. In a twist of professional vindication, it was Thwaites who reviewed Mansergh's proposal and recommended a modified version of Scheme M. His adaptation streamlined the layout, reduced costs, and reasserted many of the principles he had originally proposed. In doing so, Thwaites became the true architect of Melbourne's sewerage solution, a locally grounded vision executed on a city-wide scale. Construction began with the main outfall sewer, which would carry waste from the inner city to the treatment site at Werribee, southwest of Melbourne. The sewer had to traverse rivers, wetlands, and low-lying areas, and it included large brick-lined tunnels laid at precise gradients. Much of the tunnelling was done by hand, using picks, shovels, and sheer endurance. Earth and spoil were removed by cart. Progress was slow, but meticulous. One of the system's most impressive engineering features was the Spotswood pumping station, constructed on the banks of the mouth of the Birrarung. Here, sewage from Melbourne's low-lying suburbs was lifted by massive coal-fired steam engines and pushed into the outfall sewer for transfer to Werribee. Spotswood quickly became an icon of industrial engineering. Within its twin pumping halls, enormous steam engines were housed, cast in the UK and locally, and assembled on site. These machines ran almost continuously for decades and are preserved today at the Science Works Museum, a testament to the mechanical precision of the time. The main outfall sewer stretched more than 27 kilometres from Spotswood to Werribee. At the time of its completion in 1897, it was one of the largest infrastructure projects ever attempted in Australia. Remarkably, parts of this transfer alignment are still in use today, with refurbished and new pipework still carrying waste more than 120 years later. At the end of the line stood the Werribee Farm, a vast land treatment and irrigation site designed to process Melbourne's sewage using natural methods. The concept was simple: spread raw sewage across open paddocks, allow it to break down biologically, and use the nutrient-rich effluent to grow pasture and crops. It was an early example of waste reuse, decades ahead of its time. Over the years, the Werribee Farm became both a working treatment plant and a model for integrated planning. It provided employment, agricultural output, and public education. Today, it forms part of the Western Treatment Plant, one of the largest wastewater facilities in the Southern Hemisphere by footprint. The effect of the sewerage system on Melbourne was immediate and profound. Within just a few years of its commissioning, rates of typhoid and waterborne disease plummeted. For the first time, Melbourne had safe, sanitary streets. The city's image transformed from a health hazard to a modern metropolis. But beyond the physical infrastructure, the creation of the board marked a change in thinking. Engineers were no longer working in isolation. They were supported by government, guided by public health priorities, and given the mandate to plan for the future, not just react to the present. The board adopted a citywide planning approach that would influence Melbourne's water and sewerage strategy for the next century. Its archives, maps, cross-sections, and sewer diagrams are still referenced today. They tell a story of precision, scale, and enduring vision. And much of that original system still operates. Several of Melbourne's historical brick sewers remain active. Many are maintained by modern crews using robotic inspection systems, sonar scanning, and trenchless rehabilitation methods. While the main outfall sewer itself no longer carries sewage, it remains a remarkable piece of infrastructure, preserved as a heritage landmark and testament to the engineering excellence of the 1890s. Today, its route still plays a symbolic and planning role in Melbourne's sewerage legacy. The board wasn't just a reactive body, it was a visionary one. It recognised that sewage, drainage, and water supply couldn't be managed as separate problems. They were part of a single system, one that required long-term thinking, technical skill, and public investment. In our next episode, we'll delve deeper, literally, into the main outfall sewer. We'll explore how it was constructed, how it was maintained before being taken out of service, being replaced by the Western trunk sewer, and how it continues to provide an example of the scale of the sewer network below Melbourne, which has only grown since these early years of development. I'm Paul Michael Angus. Thank you for watching.